Last time we have touched a little bit on the file stream. We have created a new file and then write a bunch of stuff into it, and when the OF stream goes out of scope, the file is closed. Today we'll talk more about the file stream. Let's say I want to open the file and write more stuff into it. OF stream OF my log.txt. This will open the file for write. But this may not be exactly what you want, because this will also clear the content of the file. If you don't want to clear the content of the file and you just want to write more stuff at the end of the file, you need to do ofstream mylog.txt and ofstream app, which means append. And this will move the output pointer to the end of the file. And if I do of honesty is the best policy, and if we remove this line of code, then the sentence will be appended to the end of the file. Now let's say I want to write more things into the file, but I don't want to append to the end of the file. I want to write something in the middle of the file. ofstream of my log.txt. Then I'll do it with ofstream in ofstream out. Because I need to move the output pointer to different places, so I need to be able to read the file also. And then I do ofcp10 ios bg, which means the beginning of the file. Seek. This will move the output pointer 10 chars after beginning of the file. And then if I do of 1 2 3 4 5, that is 5 characters, those 5 characters will overwrite 5 characters of this 10 characters after the beginning. So this will overwrite 5 chars. And if I do of.seek p -5 ios end, this will move the output pointer 5 chars before end. And then we start writing things. Nothing ventured, nothing gained. So this sentence will be written 5 characters before the end, so it will be roughly this place. It depends on whether you are using Windows or Linux. And if we do ofcp -5 ios current, this will move the output pointer 5 chars before the current position, wherever the output pointer currently is. Now let's talk about input. We'll open the file for read. ifstream inf my log.txt, and then we have an integer I and then inf I. This will read one word from the file and parse it as an integer and then save it into I. But in our case, the first word is not an integer, so this operation will fail. So when it comes to input, we need to take the effort to handle the error status. For stream, the error status is indicated with 4 bits: good bit, bad bit, fail bit, and EOF bit, end of file bit. And if we do inf good, if this function returns true, it tells you everything is okay. which means good bit equal to 1. Inf bad, this means a non-recoverable error has happened, which is a very bad thing. So the bad bit will be set to 1. Inf fail, this is a failed stream operation, and it is a logic error which generally is recoverable, and the fail bit will be set to 1, and bad bit also will be set to 1. Inf EOF, which tells you end of file, EOF bit equal to 1. So you can use these 4 functions to query the healthiness of the stream. Now suppose some error has happened and I have handled these errors and I want to move on with my life, which means I need to clear the errors. To do that, I can use inf clear. This will clear all the error status. And I can also call the clear function with a parameter that will set a new value to the error status. So if I do clear iOS bad bit, be careful, this is not clearing the bad bit. On the contrary, this is setting the bad bit to 1. So this function sets a new value to the error flag. So this is a bit operation. It sets the bad bit to 1 and everything else to 0. So if we call the function clear without any parameter, it is equivalent to call clear iOS good bit. It sets the good bit to 1 and everything else to 0. We can also do inf read state. This will read the current status flag, the raw data. What's the usage of this function? Well, we can do inf clear, inf read state, and not iOS fail bit. This will clear only the fail bit and everything else stay the same. We can also query the status by evaluating the expression of the stream itself. If inf cout read successfully, this is equivalent to if not inf fail. We can also do if inf I cout read successfully. This is because the input operator returns a reference to the stream itself. So this is how to handle the error manually. We can also handle the error with exceptions. Handle errors with exceptions. To do that, we need to inf exceptions bad bit or iOS fail bit. This is setting the exception mask so that when the bad bit or fail bit are set to 1, an exception will be thrown. So when bad bit or fail bit set to 1, exception of iOS failure will be thrown. But when EOF bit is set to 1, no exception will be thrown. And if we do inf exceptions iOS good bit. This means no exception will be generated because of the stream error status. Thank you for watching. Feel free to subscribe to my channel and check out the other videos I have. See you next time.